Hi everyone, and a warm welcome to this Cooks and Gold webinar that is dedicated to the 2D design section for direct precious metal printing in the forthcoming Goldsmiths competition. Great, wonderful. Firstly, can I introduce you to the team, starting with myself. I'm Brian Hill, representing the Goldsmiths Craft and Design Council, and the Cooks and Gold team are David Fletcher, Head of Special Products. I've been liaising with David on this award since 2018. Maria Shipman, Additive Manufacturing and Jeweller, and Zoe Parry-Evans, also Additive Manufacturing and Jeweller. Cooks and Gold are long-term patron supporters to the Goldsmiths competition, and 3 years ago we partnered to create a new section with a total focus on DPMP. To most, this emerging aspect of technology is relatively new, different, and pretty unique, and thereby not so many of us are particularly conversant with it, hence the need to know and learn more about it. So just a little information to give you some context of this exciting incentive and excellent opportunity for designers in our 2021 competition that is action-packed with fabulous opportunities representing the spectrum of our great industry, including the Cooks and Gold Award. We made a promising start in 2018-19, where Karen Ann and Rianne both won silver awards, with Karen Ann also picking up a bronze. However, this also revealed a need to offer more advice and guidance in helping to increase knowledge and understanding of this technological process for designing specifically with DPMP in mind. In addition, the top winning designs have been produced in silver by Cooks and Gold free of charge, and this has also led to some positive liaison between prize winners and Cooks and Gold. Consequently, we staged a dedicated open afternoon at Cooks and Gold in Birmingham last October with a maximum of 15 attendees. This was great and extremely valuable. Myself and GCDC Chairman Peter Crump also attended this. We all learnt a great deal and definitely understood more about how you can design for and utilize this specific technological process that really is like no other. The seminar proved to be pivotal because most of last year's design entries demonstrated a clearer and better connection to DPMP, which resulted in an impressive and appropriate list of prizes: a gold, 2 silvers and 2 bronze awards, with Joanna winning the Cooks and Gold Award. These designs are included in the 2021 Cooks and Gold design brief on the GCDC website right now. So if you haven't already done so, please take a look. David, who represented Cooks and Gold at the judging session, was so pleased with this change and positive development. And of course, he, his team, and we at GCDC are keen and very eager to see more designers engaging in this upbeat and closer aligned way for this year's competition. With COVID forcing all of us to come up with alternative measures in our work and how we do things, here we are with this year's seminar webinar as we build on improving, helping and encouraging more designers to become involved. And we are delighted, nay enthused and inspired to have so many of you tuning in for this important session. 107 have registered. This is so encouraging, and thank you for attending. Again, reflecting on last year's seminar, the Q&A session at the end, I believe, was really helpful for all attendees. So we are keen to answer your questions and help as much as possible. So to start everything off, I will now hand you over to David.
Okay. Good afternoon, everybody, and thank you for attending today, and thank you, Brian, for that great introduction. We're delighted to be sponsoring this award once again, and we've seen great progress in the quality of the designs that we've seen in the 2 years that we've sponsored so far, and expect to see improvement again in the forthcoming award. My presentation is very short, you'll be pleased to know, and it's the more important presentation is when you listen to Maria and Zoe, who are going to provide you with much more detail and insight in how to actually design for this technology. I'm just going to give you a very brief overview of Cooks and Gold, and then talk about some of the parts that we've produced to date, outside of the competition, I should add. So let me just see if I can share my presentation. Okay, so hopefully you can all see that presentation in front of you now. So you should be seeing the front screen. So Zoe and Maria, I don't know if you just want to confirm that you can see that for me. So okay, I've got thumbs up. That's great. So we can crack on. So the Harman & Moyler Group is a large group of precious metal companies spread across Europe, headquartered in Pforzheim in Germany, but we have facilities in the UK. Western B, more familiar names to you guys, I'm sure. Obviously, Cooks and Gold, Cooks and Clare in France, Dryfout in Holland, and then Semsa in Spain. And the key message here is we are an incredibly strong precious metal supplier that's obviously supported the jewellery industry for many years. Some of the products that we produce and sell, and let's see if I can get this to flick on. There we go. So many different group product categories that we're involved in, which covers the whole supply chain of precious metals and the jewellery industry. So obviously we're here to talk about 3D printing today, but we also supply industrial mill products, standard mill products into the jewellery trade, such as wire sheet, strip, tube, casting, grain and wedding ring blanks. Dental products also containing precious metal elements. Obviously, this is all supported by our scrap and refining business. We also produce coin blanks, we produce good delivery bars, fine gold, fine silver, etc. And obviously that jewellery components that we provide via our e-commerce business and cooksandgold.com, which I'm sure you're all familiar with. And this is supported once again by our metallurgy skills, our assay offices that we have internally, and chemicals and equipment and plating solutions that we provide. So a full spectrum of products that we provide into the jewellery industry. So precious metal additive manufacturing is not something that's new, particularly for industrial applications such as aerospace, automotive, who are now widely adopting the technology, but it is something that still remains relatively new for the jewellery industry. And the key requirement here is designing specifically for this technology. We have lots of parts that we've seen that are designed to be cast, they're designed to be made from CNC, they're designed to be made from traditional goldsmithing techniques. But this is a new process which is enabling you to do new things that you couldn't do previously. So the part that you're seeing on screen at the moment is an 18-carat bracelet that was printed in 3 sections, just because of the size of the build area that we have, and the guys will go into more details on that later. But it was printed in 2 colours. So we printed the first half of the bracelet in 18-carat yellow gold, stopped the process, removed the 18-carat yellow powder, and then continued printing in 18-carat white gold. So you have a bi-colour bracelet, one on top of the other. And once again, the guys will discuss how that's possible during the brief a bit later. So what we know is that the processes and procedures that are used today have almost become principal laws. This is how you can produce things. This is how you can produce products for jewellery from precious metals. So we have to have a radical mind shift in the way that you can start to imagine products and how they can then be produced via this technology. But still, and as most of my favourite products that we've ever produced have used some elements that have been cast, some elements that have been made from CNC or traditional goldsmithing techniques, and incorporated the AM pieces that we see. So this is going to be the biggest challenge, is removing those limitations that you may have And as I say, these limitations are ingrained, that you don't know they're there. So you just have to try and push away some of those limitations and think, okay, look, what couldn't I produce previously, and can this technology be the answer to that? And once again, hopefully we can provide you with some answers as to how that can be achieved. So very, very quickly, how the technology works. We haven't got any videos today because they don't particularly work well on Microsoft Teams type webinars, but we're taking powdered metal, which we create here in the UK, and we're laying it onto a build platform and then printing the item slice by slice, 20 micron slices, which have a very, very fine microstructure, and so we don't suffer from orange peel in the same way that you could from traditional wrought processing techniques. So a layer of powder goes down, that slice of the geometry is melted, the next layer of powder is laid on top of the previous layer, and then that layer is melted onto that previous layer, and the part is slowly built up in a vertical way, resulting in a finished piece at the end. So these are some pictures from some of the videos which we normally run. So top left, you can see the actual build area. You can just about see the build area and the cartridge, which is pre-filled with a specific alloy of powder. And we can print in 18 karat yellow gold, red, white gold. We can print in 925 silver, 950 platinum, and 14 karat yellow gold. And very soon we'll also add 14 karat white gold to that portfolio. The next picture in the laser melting image, you're just starting to see a layer of powder onto that 80mm build platform, and then you'll see the powder's been applied and the laser's just about to scan across that and melt that layer of the geometry. In the third image, you're just seeing him, the engineer, remove the build platform and the finished part and the powder that surrounds the part has not been touched, it's not been melted, and can be completely reused, and that just goes back into the cartridge and is simply reused, and we can use it many times, unlike casting grain, which after several uses, grain can start to become brittle and you have to introduce virgin material. You can just simply reuse this material time and time again, because nothing has happened to the unmelted powder. So the fourth image, you're just seeing him tip the powder, the unused powder, through a sieve, which, as I say, goes back into the cartridge, and that leaves you that fifth image, the bottom left, the parts on the build platform. And what you can see are there's a gyroid, which is like a mathematical sculpture by Bathsheba Grossman, and a watch case, obviously, at the front. But you can also see the support structures that are required for downward facing surfaces, which I know the guys are going to touch on. And if I have to highlight a single topic that you need to focus on for designing for this competition, it's about where those supports will be placed, how they can be removed and finished. This is going to be the key topic, and has been the failing point on some of the designs that we've seen in the competition to date. So that's going to be, the biggest thing you need to think about. So I've got lots of images of parts that we've produced in the past now. So this is some design by a Swedish designer called Tuva Norlund. This bracelet was printed in 3 pieces, the 2 halves of the bangle and the pin, which you can just about see towards the back there. What's unique about this particular piece is it's completely hollow, it's completely empty inside, and we reduce the weight by approximately 40 to 50%, so making it much lighter. It's a very bulky piece, and it would have been very heavy and of course very expensive had we produced this solid. So a great benefit from the technology is being able to produce those hollow parts. So once again, we can see that bicolour bracelet, which we've also printed in a single colour, and that mesh, and hopefully you can see that picture in the bottom right, is completely flexible. It's an amazing design. There's a very intricate structure inside, but because you have a very flat outer surface, it's simple to polish, because going back to that support issue before, if you're producing very complex structures, you need to figure out how you're going to polish those complex structures. So that's something that should also be a consideration, and this answers that issue perfectly, because it's sealing in those complicated areas of the geometry and just giving you a very smooth surface, a simple surface that can be polished. So yeah, once again, a great design which was carried out in-house. So this is a selection of designs by a designer called Marie Boltenstern. She's an Austrian designer, and she has, once again, bottom left, the resonance collection is a mesh very similar to the one that we've shown you previously, but it's more of an open structure, so you can see inside the linking mechanisms that she's using to produce this particular piece. So once again, she's had to really think about how she's going to finish those areas that are going to be on display. The part in the top left and the far right is the Embrace collection, and this is whereby we stop the process 3/4 of the way through and remove some of the powder, drop the bead inside, and then carry on printing over the top of that. I'm sure the guys will go through this a bit later, but it's a really clever technique, but it requires whatever product is being inserted into that build to sit below the last layer that's been printed, so that when the printing mechanism then starts the reprinting process, it's not going to strike, it's not going to hit that product that's been inserted. But as I say, the guys will give you much better information on how we do that. So a couple of platinum designs, and I should say that platinum is by far and away the best material for the technology. It has a better density, and the densities in the gold and silver alloys are very, very good. They're probably higher than casting, but platinum is even higher in terms of density. The surface roughness is better also, and the print speeds are quicker. We think the reason why platinum works so well is because there's a limited number of elements inside the actual alloy. In this case, it's just platinum ruthenium, whereas in the gold alloys, for instance, you have gold, silver, copper, zinc, tin, and those elements create the parameter to be a slightly more challenging in terms of the development work that we've had to do. Yeah, platinum produces beautiful parts. This particular piece, the bangle in the left-hand side, is once again completely hollow, and we reduced the weight by about 50% once again in a platinum product. The stones were set afterwards, they weren't set during the build process. So a couple of more examples of some fine meshes that we can produce, and that mesh bracelet once again top right, but the one top left, probably difficult to see the image, but here we've printed an 18-karat white ring first of all, put that to one side, and then we started printing the outer cage in 18-karat yellow gold, stopped the process 3/4 of the way through again, dropped the white ring inside, and then carried on printing that cage around the white ring. Really good use of the technology. So just some benefits: mass customization. This is what can be done with this technology, and that co-creation with your customers, shorter time to market, and supply chain simplification. You have powder that can produce anything, lower cost of inventory because you're just holding one material, lower capital investment. This is really for those customers who are talking to us about buying the technology, buying the systems. Waste reduction, the ability to produce light-weighted pieces, hollow parts, and those complex geometries, and of course there are no tooling costs associated with this technology. So just 2 more slides, and I'm trying to keep to a time limit. We've got the sweet spot in the middle there. Is that complex geometry that can be customized, that has full functional integration, is an articulated piece. So that's that sweet spot you're trying to hit in the middle. Couple of my favorite designs, obviously bottom left, because it's a miniature version of me. I had a full body scan, and then we printed a small version of myself, and the part is completely empty inside. We were able to lightweight that. But my favorite piece is the one at the very bottom, which is a very, very simple design. This is the Sydney Harbour Bridge. And the main shank of the ring was cast because it could be easily cast. And the more complex section, the bridge section, we printed that, and then the designer has integrated those two types of technology together. So that's why it's my favourite, because it's bringing together existing technology and, of course, additive manufacturing. So just lastly, in terms of the services that we provide, obviously we have a bureau service which is going to really ramp up in 2021 when we have a fully integrated online bureau service during Q1, we believe, of next year. We obviously produce those precious metal powders here in the UK in our Birmingham facility to support the technology for those customers who have gone on to buy the system. And precious metal parameter development, we can do that for existing geometries, or we can do that for new materials as a customer requires. And then, of course, once again, this is all supported by Cooks & Gold's traditional services and businesses, that precious metal recycling and refining processes, and the ability for us to supply parts, lease material to customers who own the technology, and provide them all different ways of paying and owning the material that's being used. So I think that was all of my slides. I hope that's been useful, and just giving you a very brief overview as to the technology and how we would like to see it be used, particularly in this competition. So what I'm going to do now is I'm going to stop sharing my screen. So I'll do that first. And then I'm going to hand over to my colleague Maria Shipman, who's one of our in-house designers and AM operators, and is a fully trained jeweller as well, so understands what needs to be done in order to make this technology work. And then she'll pass on to Zoe. So Maria, over to you.
Hi, my name is Maria and I'm an additive manufacturing technician here at Cooks & Gold. You might have heard of the term 3D printing, or DMLS, also being used instead of the term additive manufacturing. They are both additive manufacturing processes for metal 3D printing. DMLS means direct metal laser sintering. It is a 3D printing process developed by EOS, which are the printers that we use here at Cooksons. They use a laser as a powder source in order to sinter metal powder. It does this by aiming a laser and tracing a cross-section of the object layer by layer. I'll be going through the following points today so you can create the best part possible for this award. How does AM differ to casting or traditional jewellery making techniques? How is a piece built? How to design for the process? And at the end, there'll be questions. So please put any questions in the sidebar and we'll answer them. We'll firstly go over the difference between AM and casting. So you should be familiar with the process of 3D printing already. Well, in AM, it is slightly different, as instead of wax or resin, and then getting the piece cast afterwards, the part is directly printed into metal using extremely fine metal powders. Here are some of the differences between the two. With casting, only solid forms can be possible, where you're unable to cast thin walls or wires. It is a cheaper process for mass production, and it's also a faster process. Parts will have pores in them. Similar surface finish to AM, whereas the solid sprues will have to be cut off and finished, and you'll have to make new molds and masters for each design, which can be a time-consuming and cost-consuming process. With AM, you're able to produce hollow forms or linked chains and meshes in one piece. Thinner walls, wires are possible to build. It's more expensive, but is well suited to unique batch production. It is a slower process for mass production. However, this can be ran overnight, so whilst in the day you're designing, at night time you're printing. It'll make non-porous parts in certain metals. It has a similar surface finish to casting, but it might be rougher in specific areas where supports have been. There are no solid sprues, just weak support structures which are easy to remove. You also have AM versus fabrication. Being traditional jewellers, I'm sure you're used to a lot of fabrication. I know when I was at university, we were encouraged to stick to these methods of soldering and welding. There are lots of benefits to using AM for your designs. Fast design to part process as soon as your design is ready. As soon as we get the STL, it can be supported and sent to the printer, so it can be a great way of prototyping ideas. Complex pieces can be printed all in one go, so there's no need to produce separate components and have to solder them together. Multiple metals can be combined seamlessly. Here you can see this bracelet, which is 18 karat white gold on one side and 18 karat yellow gold on the other side. With fabrication, it can be slow to set up and assemble new designs. Pieces are made of several components. Components can be pre-finished separately, which is a bonus. More skilled individuals or machines may be needed to complete assembly, so this can be a bit more of an expensive way of making your part. What is in a build? First of all, let's start with what happens in a build. So once the CAD design is complete, we slice the part into hundreds of layers and send it to the printer. Layer by layer, it will be printed into your desired metal, starting with supports. We can print in 95 silver, 18 karat yellow, red or white gold, and platinum 950. We are currently developing parameters for lower carats, so watch this space. We also are a research and development team, so we are always developing new alloys and pushing the boundaries of AM. Additive manufacturing is developing at an extremely fast rate, so it's a great idea to be a contemporary designer at the moment. As you can see, the support structures are made of the metal of your choice. They fix the part of the platform. They fix the part to the platform and supports it as it's being built. We can remove the supports afterwards, and these can be scrapped to save as much metal as possible. Just so you know, the platform size can be between 80 millimeters or 100 millimeters in diameter. What happens after the build? Once the build is completed, we brush away the loose metal powder from the part so you can see the build. With the leftover powder, we ensure that we reuse as much as possible as it is expensive. So here we can see the piece printed upon the platform. We then remove it by saw cutting or wire cutting the piece off the platform. Then the supports can be removed with pliers. The parts are then finished the same way you would a piece that has been cast or fabricated. The finish of the part after it is printed is a matte uneven surface. The supports that are removed leave witness marks, which can be emeryed away. The surface facing upwards is called the top skin. It is the smoothest surface and requires the least amount of finishing. There are a lot of design possibilities with AM, ones that are not possible with manufacturing or fabrication. Complete designs can be printed in one piece. Chain clasps can be done alongside the pendants, so no post-assembly is required. One of the other main advantages is that the piece can be built hollow, so large sculptural pieces can contain a lot less metal. The shape appears to be solid, apart from the small hole at the top, which can be filled later with a plug built alongside the part. Looking at the cross-section on the right, it shows that it's hollow and it will weigh a lot less. The hole allows the powder inside to be removed after building, and the wall angle means no supports are needed inside. Further design possibilities include personalization, text, and logos. Text and logos can be inserted and added to pieces very easily. There is no need for engraving once the piece is complete. You could also include your personalized brand name or assay mark within a piece. Prototypes can be created easily, as pieces can be scaled up or down and orientated differently on the platform. So there is no need for redesigning every time. You can just adjust the design you have. One of the most interesting features of AM is that you can insert elements into the build partway through very easily. Semi-precious stones can be set into the design, as displayed in the photo in the middle. We split the build into two parts, which allows no post-assembling after the build is completed. With any production process, there are some guidelines to ensure that your design is suited. Please keep these in mind when designing. I will briefly cover a few of the points on here. I would suggest when designing to refer to this page, as it will help you tremendously. Wall thickness that does not require supports needs to be 0.3 millimeters. For moving components that are self-supporting, we recommend a minimum clearance of 0.5 millimeters. For a hollow part, the release hole needs to be 1 millimeter. The smallest feature we can build is 250 microns. Please also consider additional supports within holes, tunnels, indents, and empty spaces. These are nearly impossible to remove cleanly, and if we can't get pliers in to remove a visible support structure, then AM isn't the process for your part. I will now pass you over to Zoe, who will go more into depth with the design guidelines.
Hello, I'm Zoe and I'm also an additive manufacturing technician at Cooks & Gold. I'll be taking you through the next bit of information and helping answer any questions at the end. So when designing your file in CAD, it should be one watertight solid to ensure a successful build. A Boolean union function in most CAD software will do this for you. So here at Cooks & Gold, we often use Rhino to design our CAD files. And so here are some images of what was wrong with the part and how we would like it as one watertight solid. As well as the file working within the design guidelines, it also needs to be to the highest quality to ensure a successful build. So as well as being watertight, it should have good edges and normals. You can check the quality of the components during your file prep / design to ensure it is successful. In Rhino, this can be done by analyze edge tools and then show the edges. This will then show the naked edges which need to be fixed or rebuilt in your CAD software before converting it into an STL for building. Once the part has been designed on CAD, we then use a software called Materialize Magics to generate the supports. Support structures must be added to the part to fix it to the platform and to support any horizontal areas. Parts will not build successfully directly into loose metal. Angles 45 degrees or less from the platform will need to be supported. The design of the piece can be modified to be self-supporting, so minimal support is needed, which is obviously preferred. It eliminates processing and the need for unnecessary supports. Downward facing surfaces are generally slightly rougher than vertical upward facing surfaces. So we take this into account when we orientate the part, and also you should take this into account when you design it as well. Detail is more accurately produced when it is not built facing downwards. So here are some design guidelines that go through how you would design in reference to supports. So as mentioned before, we ideally want as little support as possible, as the supports are actually removed by hand after the part has been removed from the platform. So you need to make sure that all the areas with supports are accessible with pliers. So on the illustrations, you can see the part, and then the red areas are the supports that would be required. So the overhanging edge on this piece is under the 45-degree minimum angle from the platform. So supports must be added to allow it to be built successfully. If supports aren't added, that can mean the part can burn or collapse in on itself. So the supports are needed to hold it up. The horizontal surface on the bottom part would need supports all the way along it to be successful. So here's a bit more information on how to design for the supports in mind. So you can reduce the need for supports by changing the wall angles or removing the horizontal areas. So the shape has been changed to a triangular one, as triangles are self-supporting, so the need for supports is completely removed. With holes with a diameter of 4 mil or less, these will need supports within themselves. We can angle these supports out slightly to eliminate the damage caused to the part, but ideally we would like no support within the hole, because otherwise it's very hard to access that area to clean it and finish it. So you can change the shape of the hole so it won't need supports. So you can see above they've changed it to slightly triangular to be self-supporting. So it's important, as mentioned before, to design for the process and not design a part that looks really good and then trying to apply it to AM, because most of the time it won't be successful. These are some designs that have been submitted to us a while ago that we couldn't unfortunately produce as they had some design constraints. So the part on the left had an overall wall thickness of less than 1 mil over the whole part. So the blue areas are the areas that would need supporting, which would attach it to the platform. Because the part is so thin, once it's removed, the removal of the supports could easily misshapen or even break the part. So that's why it wouldn't be successful. The part on the right would need support generated in between the whole of the design, as none of the areas are self-supporting. You could eliminate this by making all the angles triangular, and then they wouldn't need supports in the inside. So in regards to all the constraints and possibilities of AM, here is a piece that was perfectly designed for the process. So the design has an interlocking form that can be printed in one piece. It's self-supporting structure, so limited supports are needed and limited supports are to be removed. The time to remove the supports then is dramatically decreased. So inside the stone settings, it was a pyramid shape, which meant there was no need for supports. The only supports that were required were to attach it to the platform, which was amazing. So finally, it's really important to remember when you're designing, can it be supported? Can it be printed successfully? And can it be finished to a good standard as well? Okay, so then we'll go through some questions.
Okay, can I be heard? Okay, smashing. So many thanks to Maria and Zoe for providing us some details there on how to successfully work with this technology. So we've had a series of questions that were submitted beforehand, and we've had a number of questions that have been submitted during the presentations that were made. So we're trying to address all of those now. I'm going to try and moderate to the best of my ability, and then aim these questions at the guys as required. So leave it with me to just bring those up. Did you want to take the presentation down? Stop sharing that for us, Maria. We might as well see some people during this part. And Jess, I'm not sure if you can have Maria, Zoe, and myself, and maybe even Brian. Okay, so it's just me then. It's just me that you're going to see, and unfortunately, so. Which is a shame. I've got a suicidal cat that's throwing itself at the door at the moment, so that's always going to make things interesting. So, okay, so I'll go through the questions that have been submitted since we started the presentation, and then we'll go to the ones that were submitted beforehand. And as I say, keep them coming. Probably the answers that we provide are going to be few more questions as we go along, and we hope that this section is actually going to be the most detailed section because we're going to answer specific questions that you may have. So the very first one, and I don't think Brian was expecting a competition, but I'm going to throw this one at Brian, is can anyone take part in the competition? This is from Shirani Fernando. So you're on mute, Brian. You know, I don't think anybody has got through a Teams meeting yet so far in these lockdowns since March without saying to somebody, you're on mute.
It's a common experience. Yes, the competition has always been open to anyone. For all the years the competition's been running, it doesn't matter whether you're a hobbyist, a student, a professional, a company, an organisation, whatever. So it's free to enter. As long as you have designed and or made it in the UK, it has to be done within the UK. These are nationwide awards for the UK, but there's no bar on anybody, age or background, as long as you are doing it in this country.
Okay, Thank you, Brian, for that great answer. Wendy, who's asked a number of questions, so we'll try and address all of those for you, Wendy. What is the relative pricing versus casting, and what are the production times compared to casting? So this is all dependent. I'm going to ask this one, guys, rather than pass on to Maria and Zoe. This is obviously dependent on the geometry in terms of time to print. The taller the piece, the more slices required, the longer it's going to take to print. So it is very much geometry dependent. But you know, if you were to produce a simple ring that's laid on its side, so a very shallow geometry, you know, no more than sort of 7 or 8 mil in height, then you're probably looking at, you know, 1 or 2 hours for that. If you start, as you start to go higher, then of course the time is going to be longer, and if the part is bigger, then you've got more area for the laser to melt, so that will also have an impact on the time. So it's very much geometry dependent. In terms of how does that time compare to casting, it's immeasurably shorter, because there's one process step. There's powder, and then you're printing it. That's it. There's none of the requirements to produce the wax or the resin, and then producing the actual casting and de-spruing, etc. So it's a completely different process and very difficult to make a comparison. In terms of costing, once again, because it's very geometry dependent, more layers equals more time equals more money. But it also depends on the yield, so the amount of support structures that might be needed for that particular piece, because the support structures, a bit like the sprue of a casting, are scrap. They have to go into the scrap pot. But unlike the sprue in a casting, which is a solid feed into that part, the supports that we use for additive manufacturing are hollow. They are like a honeycomb structure inside, so they're very, very lightweight. But yeah, those supports still have to go back through the scrap and reprocessing that we do here at Cooks and Gold. In terms of pricing itself, if you were to produce a single, we go back to that ring, which probably isn't a good example in terms of what should be printed and what shouldn't. But if we go back to that simple ring, if you're producing a single piece from casting that's going to have a master produced and then go on to be cast, versus producing a single piece for additive manufacturing, and this could be 60, 70 pounds, then it's probably the same. If you go on to produce hundreds of pieces from that master from casting, of course, casting is cheaper. And in general, casting is cheaper. And we have to keep reiterating this. This isn't to replace a process that you're already using. This is a process to enable you to do things that you couldn't cast previously. So those interlocking structures, those hollow parts that we've been talking about today. So next question from Shirani, can you make multiples of the same? And then obviously, is it cheaper to casting, which hopefully I've just answered. So yeah, absolutely. We have an 80mm build platform, and the parts you can fit as many parts as you can onto that build area, and you can also stack products. So using that ring as an example again, you could stack the rings on top of each other and produce as many pieces as possible. I think we produced 47 rings in a single build, which were, I think it was an array of 7 pieces, which were then stacked up to the build height of the parts. But at the same time, you could produce lots of different pieces on that build platform at the same time. So you could have 5, 6, 7 different designs all being printed together in the one build process. So an anonymous response was, how thin can the wire walls be? So Maria, do you want to address that one?
Yeah, they can be 0.3 millimeters. What I would say, if you are going to go to that thin, we would prefer them to be maybe self-supporting, but it can be done. It all depends on the design as well.
Okay, smashing. I'll ask, you may want to share this between you, but can hinges be printed? This is from Wendy again.
Well, hinges is something we were actually looking at recently. Hinges and rotating wires. In theory, yes, they can be printed. It's something that we definitely want to look into, so it'd be quite interesting to have a few hinge designs come our way. But in theory, if the hinge is self-supporting, yes, it can be printed.
Okay, Smashing, so that's a positive. Do you get any, Wendy has asked again, do you get any shrinkage during the process? And the answer is no. This is different to casting, where there is shrinkage obviously in the production process. So no, we don't see shrinkage in the same way that you would do with casting. So this is another benefit when you're producing certain sections, certain complicated designs. You're not going to have to make an allowance for what the shrinkage may or may not be. Next question. Did you print last year's winners and can we see them? So yeah, we're in the process of doing that. Obviously COVID has stepped in the way of most things that we've been doing this year. The winners were announced, as you know, back in the award ceremony back in February of this year, and then immediately afterwards we went into lockdown, and unfortunately Cooks and Gold had to shut for a period, and then we had a lengthy period where we actually closed down our AM business to support our logistics area. So it was just a very short period that we decided to focus on our e-commerce business. So we're back doing the designs and looking at products, and we're working with the three winners, the two silvers and the gold winner Joanna Strinsky, as Brian mentioned, and we're endeavouring to get those parts printed. So Maria, go on.
We're printing it next week, so we might put some stuff on LinkedIn to show the process in full.
Fantastic. That's great news. Yeah, I think there's at least two of them have come forward that they've wanted to have them printed. So yeah, so really positive. And as Brian said, the quality of designs was far greater for last year's competition than the year before. So we're looking forward to what you guys will come up with this year. Can
I say something, Dave? Just one of the things that we were really trying to establish, especially last year, was can this design be produced by this process, this technological process, and not in any other way? Is it, in other words, is it totally suitable for this and not another?
Yeah, I think that's a great comment, and something that really needs to be thought about. You know, Maria said it in her presentation, and so did Zoe, that yeah, it's great that I think it was Zoe actually that you can produce, you know, an amazing design, but if you've not thought about the process, as you would do for any other products that you produced, if you haven't thought about the process that you're going to use to produce that part, then it's going to cause some issues. And of course, if you know, we will be able to see that when we judge the designs as we do. That, you know, is it going to be possible to print? Is it going to be possible to remove the supports? This is the key moment. Wendy was asking about inclusions. Can stones be included, or will they be damaged by the heat from the lasers? Yes, absolutely. Stones can be included, as we showed with the coloured beads, which the designer Maria Boltonstern has done. The unmelted powder, the temperature in that build area is about 45 degrees, 50 degrees. We know this because we had a customer that wanted to encapsulate a human hair during the build process, so we had to test the temperature. So the unmelted areas of the design, the temperature is relatively low. So there's no damage to the stones, and we've put semi-precious stones inside and precious stones that the Boltonstern uses, and there's been no issues whatsoever in doing that. Anonymous, is there a heat element that is going to inform what you can add inside the print? Yeah, I think it's the same question. So yeah, pretty much anything can be inserted that can be encapsulated during that build process. It shouldn't be a problem. Maria, thank you. You're on mute, Maria. You're still on mute.
Sorry. Just to say that anything that we do insert needs to be below the line of the powder bed. If you're inserting something that's big and long and tall, the printer then cannot go across the powder bed and carry on the print. So always take that into consideration when we insert something. Okay,
thank you. So yeah, it's I think I said in my part of the presentation that as long as we bury that part below the last layer that's been printed, so that the application of the next layer of the powder, the recoater, doesn't strike that part that's been inserted, then it's going to be fine. So Wendy goes on and asks who can provide affordable CAD training. I'll throw that open to either Zoe or Maria.
We often use, well, we've been doing a course over at BCU to advance our CAD training. There's also a lot of online resources that you can use. There's even YouTube demonstrations which go through step by step, which are really good. Even if you've never done any CAD before, they really help. You can follow that side by side, the video and the CAD software.
Yeah, there's also a website called Udemy as well, and you can pay like a small subscription for a teacher. So some of them range from $5.99 up to $100, and they will teach you from being a starter all the way to being intermediate. But what I would say is a lot of these things you can find free on YouTube. And that's how me and Zoe have learnt most of the stuff, is just on YouTube. So.
Just to add to that, there are CAD courses at the Goldsmiths Centre in London as well. And I do know there are a few people that do private lessons for CAD as well. So there are a number of options for people. So there's plenty out there. It's just actually connecting and to them.
Cool. It's also worth remembering that the output from those, and there's lots of different CAD software you can use. We use Rhino, but there's many others. The output file that we would be looking for is an STL, which is the sort of the standard format that comes out of CAD software. So we had a question. How do we clean up the last necklace pictured with all the intricate interlacing wires? So this is the Lionel Dean heart, which I think appeared on your final slide, Zoe, of the presentation. So the answer was there wasn't much finishing applied. The internal areas were left as printed, which is like a matte satin effect, similar surface to a cast piece. It was just the outer sides of that particular piece that were polished. It went through general polishing processes. An OTEC system was deployed to do that, and we also used some electro polishing as well. So I think you know, we're working on different ways of polishing products and addressing those issues that I mentioned at the beginning about how to get into those intricate areas to get them polished. But in most cases, there might be a little hand polishing that will be required. And if you want to add anything to that, Maria or Zoe. Oh, I answered that well.
No, any traditional finishing technique is used.
Very good. So can the design be submitted by hand drawing, or can it be a CAD presentation? Brian, I think you can have that one.
I would assume that you would need to have it on the technology platform rather than hand. We did have a winner last year, didn't we, David, with a hand presentation. So, and that got a silver. So I think as long as it hits the buttons of the criteria, perhaps you would confirm or otherwise that it's quite acceptable to come in with the way that you would like to present. The key thing is it suitable for the technology? Is it a great design? And will it work?
Yeah, definitely. And I think it's going to be much easier for us to assess the design properly if it's submitted in a CAD format, and we can actually see the STL, we can see the geometry. So as Brian said, we did have a winner last year that was a hand drawing, but it would be better to actually see a CAD design. Yeah, we'll leave that to you as to how you want to present those to us.
It's just to remind everybody, David, out there that because of COVID, we're doing a totally different format this time, and all 2D design sections in the competition, of which there are 10, with Cookson Gold in there as well, will be judged by our judging panels, by our industry experts, online exclusively, quite opposed to anything we've done before, which was in person, even though in your section, we obviously had computer screens and played videos, etc., according to what people submitted. But so this time it is totally online, which to help us to help you, the best way, as David's saying, is to do it through a CAD file.
Yeah, perfect. Thank you, Brian. It's a crazy year this year, and so yeah, we're all getting innovative as to how we need to do things, and hence our first webinar, which I'm hoping is going okay so far. So anonymous question: is the piece made by printing equally as strong as a casted piece, as a printed one that's made from this technology? So Maria or Zoe, do you want that one, or do you want me to answer that one?
Yeah, it's equally as strong as a casted piece. There's no difference in how it's produced. It's less porous than when you cast something, so I guess that can affect kind of its structure, but no difference in strength. Yeah,
I have to be careful.
What about in hollow form? When you're doing the hollow, there was a bracelet there. Is there any issue as far as wall thickness and strength? It's gained in weight, it's gained in cost, obviously, because of that. And amazing. So a large bangle, I forget the designer's name, looks very impressive, because you would think that would weigh a ton. But so it's got many gains, but that, to me, would say, well, how strong is that through that process?
Yeah, I mean, I don't think the guys were with us when we actually printed that part. It's by a designer called Tuva Norland, and the bracelet was thicker than the 0.3 mil wall thickness, which we recommend, but she also put strengthening features inside the design. So if you were to cross section the bangle, like the cross section of a wing of an aeroplane, you'll see sort of a lattice structure inside that's adding strength. And you can do the same, and there's many different ways of doing that. You can provide that lattice structure inside to give the strength, or if you have you can put some sort of corner wedges in within the design to add strength. So there's lots of different little techniques in order to get that strength inside. What I will say about the original question is, we're printing in 20 micron slices, so it's an incredibly fine microstructure, and it gives it great flexibility inside and malleability of the material. So a cast ring, you would put it on a ring stretcher, and maybe you go 2-3 finger sizes before you start to see, real signs of stress and orange, obviously orange peel. We can go 6 or 7 sizes with a printed ring because of that really fine microstructure. So it's a very similar strength and cross section to a wrought piece, a piece that's been rolled, annealed, as opposed to a casted section. If you are printing a hollow sealed form, should it have holes for removing excess powder? Yeah, great question. And Maria, you can answer that one.
Yep, so the hole should be a 1 millimeter in diameter hole. We can also fill the hole with a plug now. So when we do finish the part, release the powder, we can plug it back up, and once it's emeryed, you can't tell that the hole is there. It's like a solder seam, and once it's finished properly, you can never tell it was there to begin with. So we can have a full form that's hollow with no hole in it at the end.
Is that hole plugged up by laser welding or by more sintering?
Nope, we sinter a plug, so it's almost like a plug that goes in a bath. We literally put it in the hole, push it in, gently tap it in, and then emery it back so it can't be seen.
Good question, though, and key. Yeah, if you're producing a hollow form, you have to have some exit holes to remove the powder that will be trapped inside. So yeah, that needs to be thought about. And if we're in the judging, Brian and I will be able to tell you that if we're seeing that in the submissions that are made, then we know that you're thinking about how to design for the technology. So that's something to consider. Marina asks, when would you need internal support for hollow parts? Does it depend on the size or the gap or the shape, or both indeed?
Oh, okay. So internal supports will be needed like anything else if it has an overhang, and supports needed to keep the part held up without collapsing. So what I would always suggest with an internal hollow piece, because no one's going to see it, that you make it into that triangular form inside so that it's self-supporting. This means it's cheaper for you as a customer, and also it directs the powder straight away out the hole, So it makes sure that there's nothing kept inside the part. I think that's, yeah.
I think that covers it. So yeah, those strengthening features are key. And once again, if we can see that cross section and know that you've done that, then once again it really demonstrates a good understanding of the technology. Are the 18-karat gold prints good enough for setting, Zoe?
Yes, they are. We print lots of designs that have like different stone settings already, and then these are obviously set by the customer themselves, and they're just as good as if you fabricate it or if you cast it as well.
I'll ask a follow-up question to that then, Zoe. Could you set within the process?
You can do, yeah, as long as it's similar to the insertion technique, as long as the stone that you're putting in isn't higher than the actual part itself at the time, then you can design it to set it at the same time.
Okay, right, that's good. That's good to know. Wendy's asked again, are files from Fusion or SketchUp software usable, Maria?
Yep, they are usable as long as we have an STL file sent over. Any CAD software is fine to use.
Okay, very good. What's the surface finish like compared to a cast print?
Me? Oh, sorry.
Yeah,
so the surface finish is matte. Sometimes it can be slightly uneven, maybe a little bit grainy on top, but not so much. The top surface is always the best surface to look at. So if you've got anything with high detail marks on them or features, then what I would suggest is building it with the top with that on the top and facing upwards. On the below part where the supports have been, once you remove the supports, you will have witness marks, some sort of puckering. They're really easy to remove with emerying and traditional finishing techniques. And after that, it will look like any other piece of jewellery that you've had cast or fabricated.
It's worth remembering that those supports are attached via small teeth to the part itself, so they can be removed simply with pliers, as you mentioned in your presentation. And quite often we see customers do that and then start to polish immediately, and then they're looking at what they think is porosity, but in actual fact it's just the residue, it's just the remnants of that supports. So you need to cut that support, those support teeth, those remnants of those supports away, and then polish, and you'll get to a very sound material underneath the supports. It sounds detailed, but it really isn't. This is a quick lick over to remove the supports and then start polishing.
Can I ask David, something that is hollow, and you've mentioned a 0.3 wall thickness, clearly that's got to be the most acute finishing process to something like that, otherwise you just go through it, wouldn't you?
Yeah, you have to be careful, and we have watch manufacturers that use the technology, and they're looking at very fine specifications for moving parts that need to be inserted. So yeah, you just have to be cognizant of the fact that if you're going to heavily polish and finish, then the part is, if it's very thin, then you need to just be cognizant of that. The guys, Zoe and Maria, are obviously very skilled at that. They do it all the time, but this, once again, as part of our standard 3D printing service, we do this work. We remove the supports and actually get the part ready for final polishing. So who adds the supports? Does it need to be done by the designer, or are you guys going to do that, Maria?
Yep, we add the supports. So we will find out any faults with the part before it goes to the printer, add any supports, and communicate with the customer to check that everything that they want from the part, it goes to plan when it gets printed. Yeah. Okay.
I think, Jess, you've answered the next one for Wendy, which was, what is BCU? Birmingham City University, which is directly opposite our building here in Birmingham. Is the surface like a high resolution wax print?
No, with wax prints you can see quite a lot of the line work of where the printer has been. You don't get that with our printers. You might have a grainy texture, but it's not in the same aspect of a wax or resin printer. I would say actually the surface is a little bit better than a wax or resin printer. Not as smooth, but not as the lines can't be seen.
Okay, thank you. There was a question asked about Udemy, and thank you, Jess, you've provided the details for that one, so that's great. Can the prints be polished in a polishing tumbler?
Yes, they can. We often use the polishing machines that we supply at Cooks and Gold as well. So it can be finished like any standard part. You can use it to sand down the edges to make it a matte finish, or you can put it in like a high polishing barrel and it comes out fine. So it can withstand the movement as well.
Okay, thank you. If printing a piece in separate parts, what's the best way to then join them together? Laser, can it be soldered normally?
It can be soldered normally, but I would pose the question, why wouldn't you have them already together if you're printing it? So that's what I would say to that.
Yeah, I mean, I think that's a perfect example. And there are obviously cases where you're going to have to do, you know, standard jewellery goldsmithing techniques afterwards. But if it's an intricate part that's in different sections, then, you know, have a look at trying to produce that in one piece within a single build. So that's what I'd say to that. I'm just going to share my screen again, and hopefully you're going to be able to see this. And what I'd like, if possible, Maria, hopefully you can see what I've just shared, is just to go through that again. It's a nice big picture that we have of that now, hopefully on your screens, of the design guidelines. Just line, you know, piece by piece, just to cover it in as much detail as possible.
Okay, so with the first section where it says minimum wall thickness is 0.3. This is regarding stuff like ring shanks, inside of pendants, bracelets that you're going to be producing, making them hollow but aren't traditionally hollow. They need to be 0.3 millimeters, as we can't get in there to then remove the supports or the structures that you're putting in there to keep it upheld. Going on to the minimum embossed and recessed detail, they need to be in width 0.3 millimeters and in depth 0.5 millimeters. Anything larger than this will need support from us. From the unsupported horizontal surfaces, the max overhang needs to be is 0.5 millimeters in length. Anything larger than 0.5 millimeters in length will require support. So we can have a small lip around a surface that doesn't require support. The support angle needs to be 45 degrees. We can angle out supports. So if you have got something like a ring, like you can see on the picture, we can get the supports and move them out so it doesn't touch the piece again. We do prefer that the support isn't touching between two parts of the piece. So the maximum build volume is 80 millimeters in diameter. This can also go up to 100 millimeters in diameter if we go on the M100s. And the Z-axis, so how tall it can be, is 90 millimeters. What I would say to this is people in the past have sent us parts that are exactly 90 millimeters tall, but don't take into account that we actually have to add on a support structure underneath. So then it becomes too tall to be built. So if you are sending something through, I would probably try and work to 85 millimeters. The minimum unsupported tunnel is 1 mil. Anything over 1 mil in diameter will need support inside. So what I would say is make sure that they're easily removed with small pliers, or amend the top of the tunnel so it is self-supporting. With the minimum vertical holes, they have to be 0.5 millimeters in diameter. Anything taller will then require support. And what we need to make clear here is the reason why we say this is otherwise it can lose definition and sometimes collapse. Once it's lost its definition and collapsed, it requires a lot of post-processing to make the part look how you want it to look, if it can be done at all. The minimum clearance between two parts is 0.5 millimeters. So if you are creating a mesh or a bracelet or links, make sure there's 0.5 millimeters in between each part, only because if they're touching, they will then weld together and there won't be any flexibility potentially. The minimum powder escape hole, as we said earlier, is 1 millimeter, so we can remove all the powder from inside a hollow part. The smallest buildable feature is 250 microns. The minimum pin diameter is 0.8 millimeters. If the pin and the wire is too thin, it will struggle to stay straight during the build, as although it won't be touched, there is a moving part in the printer that can disrupt any part of the build. And the tolerance is 100 microns for the X and Y axis, and then 20 microns for your Z axis. So if you want to have a look at building a larger part that goes on the platform, please keep that in mind.
That's brilliant. Thank you, Maria. And I think, Dan, that answers your question that you've posed regarding the minimum gap that you want to leave between parts, as shown in that tricolour piece. And I think that's shown here as 0.5 millimeters. The tricolour bracelet the bicolour bracelet, it's two colours that we showed you. That wasn't a ball joint. They were interlinked cages that sit between that particular part, but ball joints we've also produced in the past, and they've been very successful. So I'm just checking. Would you add earring pins to the print, Maria?
So we have, for some customers we have done in the past, and for other customers we haven't, and they've soldered them on afterwards. It all depends on how you want to support your part, because a lot of the time the earring pins obviously go on the underneath part of a build, which will then mean that it will need supporting, and it will be mixed in with the support, which will just mean it will be really hard to pull off. And a lot of the time we actually accidentally pull off the earring pin with the support structure. So what I would say is it can be done, but also you need to recognise that there's probably some work that needs to be done on the other side that you need to look into as well. So,
you know, if we use that minimum pin diameter diagram as an example, imagine that's an earring with a pin. Then you've increased the build height by about 10 times by actually printing the pin. So you looking at that, you'd say no, immediately you should add the pin afterwards, which are obviously sold by Cooks and Gold. It's just about what's the right way, what's going to be the most economical way of using the technology. So
can I also say that, going back to that picture, that if you are using that as an earring, the other side of that hexagon will have some feature on that you've put on there, and it will look really rubbish because of the supporters that are going to be put on.
Okay, smashing. Thank you for that. We've got some questions that were submitted beforehand, so we're trying to address some of these as well. So the costing of the process and execution would give a better understanding of for my particular work. This was can't actually see who submitted these questions. So once again, based on the cost, it really is dependent on, it's geometry dependent. We do have some examples that we can share offline about different products which are used as benchmarks. But the taller the piece, the more supports required, the more it's going to cost to produce. If you minimise the height, minimise the support, so the yield is better for our powder, then of course the part will be cheaper. So it's a question of really working with us to understand the differences in cost. But once again, you should be able to compare anything that you want to submit for 3D printing, in that it shouldn't be able to be made from any other technology. So how would you make a comparison in costing? So another question about the minimum wall thickness, which I think we've already covered. Do let me know if we haven't. How expensive is it to print compared to casting? So once again, I think we've covered that one. Production time and cost concerned. Again, I think we've been through that. So I think a question that's worth answering: design restrictions and comparison of those with resin printing. I don't know if you can answer that one for me, Maria or Zoe.
So with resin printers and wax printers, they have a different support structure. So when something needs supporting, it can be dissolved away, whereas ours can't be dissolved away because they're made in metal. So we have to remove ours physically, as you would a sprue, except it's a lot easier to do than a sprue. So what I would say is we can't do parts that have lots of tiny little gaps unless they're also self-supporting, as we can't melt away the support structure. So that'd be the main difference.
Thank you. The minimum maximum wall thicknesses you can print in silver and gold. I think we've already covered that, but these design guidelines apply to all of the metals that we produce. And to reiterate what they are: 925 silver, 950 platinum. It's a platinum ruthenium alloy. 18 karat yellow, red and white, or rose gold for the red, and 14 karat yellow with 14 karat white coming soon. Just one comment I wanted to make about bi-colour printing, because we've seen the bracelet that we showed earlier in the presentation. We can do bi-colour prints in the horizontal plane. Okay, and this has been a particular issue with one of the designs that we're trying to work on at the moment, in the fact that we can stop the process. So the part is oriented onto the build platform. We can stop the process, remove the powder that's been unmelted, leaving the solid half produced part inside the machine. We then backfill with a different alloy and carry on printing in that different alloy. So we can only do 2 colours, maybe even 3, although we've never done it, if you are doing those interchanges between the colours in the horizontal plane. So that bracelet was printed flat on the build platform, and halfway through we stopped, removed the yellow powder, backfilled with the white powder, and then carried on printing in 18 karat white gold. So that's really important to remember. It can only be done bi-colour or tricolour in the horizontal plane.
David, just to add to that, on our visit, the open afternoon last October, you had 2 of those bracelets, a wider one and a narrow one, with the 18 karat yellow on one side and white on the other. Just to reiterate the value of this technology to produce something like that, that is start to finish produced on the machine, and including the catch. The flexibility is like a snake. It was so impressive to see how that can be produced. And if I try to imagine making that by hand, I think I'd have to go into a room and have put some headache pills in myself. So that was a terrific example to me. And the narrow one, which was, I can't remember the actual width, to get all that detail, flexibility, polished surfaces, bi-colouring, snap system, is just sensational. Am I going too far there, David, or is that?
No, I think you're absolutely right, Brian. It is a remarkable piece, and even more importantly, I think the fact that it's such a simple surface means that it's simple to finish. So yeah, it really is a great example of what's possible from the technology. Closing off that internal structure, which would have been really difficult to polish, with a nice flat surface, a very simple surface to finish, is really good use of the technology. So I think most of the questions that were submitted beforehand we've covered off. There's questions about density, which once again was in the presentation, and just to reiterate, it's above 99.5 for all metals, but higher for platinum. Can we print in more than one material, as I've just explained? So hopefully that's covered everything that we had submitted beforehand. So a couple of points worth making is that this presentation will be available to view. We've recorded this presentation today, so it'll be available to view via the link that you used to actually log in today. I think it will also be added to our additive manufacturing website, so you can check it out there. You'll also find some of the other resources, such as the design guidelines, on that website. I think we're also going to provide you with the email addresses for both Maria and Zoe. So if you have any questions, and we really strongly advise you to do this is to contact these two guys directly. They'll answer your questions, provide some advice, and we certainly saw that the entrants last year, we weren't aware because I don't know, as part of the judging team, I don't get to know who's contacted and done what in the background, but we found out subsequently that the guys that contacted Maria and Zoe prior to their submission last year ended up in the finalists. So I think it's a really good resource to tap into these two guys and ask some specific questions about your specific designs. Okay, so Maria, Jess, did you want to step in?
Apologies, there's been 2 more questions that have come in. So how much is the processing is included in part of the service, and is the metal soft or work hard?
So what we do after the part's printed, we remove any evidence of the supports as much as possible. We don't file and emery the whole part itself. That's up to you because that's your desired finish. Some metals, I think, I'm a bit confused by the question, but silver is slightly softer metal to work with after it's been printed. But once you finish it, it'll become hard, similar to the other alloys. I think that answers the question.
And then this is from Anonymous. I'd heard that welding a 3D printed piece can make it explode. Is this correct?
It's not something that we've heard of, so I don't think that's correct at all. I'm guessing they're talking about laser welding or traditional welding. No, never heard of it. It doesn't happen. Yeah, you can use laser welding to attach the parts together, or traditional welding if you want to use that process.
I'd say it's similar to traditional jewellery, as long as there is a gas release hole. If it's a hollow part, then there shouldn't be any explosion. If you're welding a hollow part with no gas release hole, then yes, there will be an explosion. Yeah.
Good question, actually. I've not actually had that. You know, I've been doing this for a long time, and so have the team, and I've fielded most questions, but that's the first one, so that's a good question. Jess, I think I can see the remaining question that's there. Would you recommend a course that is specific to designing 3D printing, Maria or Zoe?
Yeah, like I said, there is a guy on YouTube called PJ Shen. He should give me royalties because I must make him a killing on advertising. But he is really, really good if you are new to to designing in CAD. I'd also go on the Udemy. It might cost you a little bit of money to go on Udemy, but some of them start from a very low price of £5.99, and the ones that go up to £70 or £80, they're worth it. They're yours for life. Once you paid that subscription, you can go back to them as much as you want, and it's definitely a worthwhile investment for your CAD design.
Okay, I think that's most of the questions. You know, it's worth reiterating again that don't design in isolation. We've given you the resource now to tap into Maria and Zoe's knowledge, so they should be able to help you to do that. We want you to be successful, and we want to have the quality of files and submissions that are made to be as high as possible. And you know, let's work together in order to try and get you to produce or to design a really good piece for this technology. We've shown you some great examples today of other designers, some internal, some not, that have taken good use of the technology. Some of the resource that you could go to, I'll plug a few of our customers. We've already mentioned Marie Boltenstern, who does the insert builds with the Embrace and Resonance collection. We have a customer called Heinrich and Denzel. They're a German jeweler that have a system, and they are producing some stunning designs in platinum from this technology. So definitely check out Heinrich and Denzel. We've got some watch manufacturers that are using the technology and are very successful with it. So these are the resources. These are the areas that I'd be looking for inspiration as to what they're doing. And you know, we've been saying that you can produce these really complex structures, and what we've seen in the past submissions that they are really complicated designs, which is commendable, but then not really thought about how to make that work in this technology and how it could be printed. So it could be that a more simple design would be better suited if it's really tapping into all of those different aspects that we've spoken about, hollow, with support structures inside to gain the strength that you might need for that particular piece. That mesh where you can't actually see the mechanism inside the mesh, but because it's so simple to finish, is once again a great design. That hollow platinum bangle produced in a single piece, which was empty inside. It's brilliant design for the technology that couldn't be achieved, and it's worth mentioning that once again that platinum is such a good material for this technology, that whereas we say in general this isn't to replace what can already be done, so it's not a replacement for the casting process, in platinum, well, maybe it could be, because the platinum prints are so good for this particular technology. So Jess, how are we looking?
Yeah,
okay. I'm getting the thumbs up. Brian, did you want to add anything?
Yeah, just to round up to say thank you to everybody, including Jessica, who's the mastermind organizer behind all this. Having attended last year's, well, being with this from the start, I think this to me has been really helpful. And just a pointer again, backing up what David was saying, do use this amazing resource that's being offered to you. Joanna Storanska won the gold and the award last year, not by a country mile, but it was the top favourite. She was in that seminar last October and very proactive in asking questions, and I'm sure followed it up with the offer to say, and that was a relatively new introduction for Joanna, because she's a brilliant maker, setter, polisher, craftswoman, so it really worked for her, and we were obviously thrilled that support and help has taken somebody through to do something new for them and added to their capabilities and skills and portfolio, which is terrific. So do use the resource that's right in front of you now. I think that's brilliant. And just to say that the competition details are all on the website. The entry date, the portal will go live, application portal will go live at the end of this month. There'll be lots of help through our new system, re-COVID, and judging will be next year, and all help will be there. There'll be frequently asked questions. There'll be people available to answer anything that may well come through for any questions to do with the competition. So we're nearly the same as normal, end of January rather than mid-January, and we're looking forward to even more ideas coming through. And this seminar has obviously, for me, has helped big time to encourage more and educate and inform. So thank you for everybody for a cracking session, and I hope everybody watching is thinking the same as well.
Yeah, thank you, Brian. That's a great summary. You know, we're really looking forward to seeing some designs. What we'd love to do is to be able to put some of this competition's winners in this presentation that we provide this time next year. That would be the ultimate goal, to show the results of what's possible. Thank you to Maria and Zoe, and of course Jess in the background, which none of you have seen, but she's done a great job today. And thank you for your time again today, Brian. Let's see some great designs coming in. I know that Jess is going to follow up with lots of resources for you and details of the designers that we may have mentioned, and hopefully we've answered your questions. And if we haven't, then you've got the details from Maria and Zoe to do so. So I'm going to finish up by what's become tradition for the end of meetings, which never happened in the boardroom before, but we're all going to wave and we're going to say cheerio, and thanks very much for listening today. Take care.